Okay, now you know about different classes of IPv4, and I want to talk about the default subnet mask for each of them. And of course, I want to talk about the concept of subnet mask a little bit here so that you have an idea of what subnet mask means. So, again, I'm talking about 8 bits. That's very easy to talk about only 8 bits, okay? Now, if I write 8 bits and I want to put a cross for each bit, this is 3, 4, 5, 6, 7, 8. We have 8 bits and each one of them can be 1 or 0. So, based on the fact we have 2 to 8 different situations, 2 to 8 different, combination of the ones and zeros here, that is about 256 different combinations. Okay, now if I want to put all of my devices in one section, I can have, for example, 256 devices in one section, and all of them can ping each other. All of them can talk to each other. But here, I want to create different sections. If I want to create different sections, what I will do is to divide these bits into different portions, and each portion will talk about one section. For example, if I divide these bits into two different areas, the left part can be the section ID and the right part can be, for example, the host ID. The host ID is the ID of the device that is, talking to the other devices. For example, a computer, okay? Now, this one, I have, separated only one of these bits. It has two different values, 0 and 1. So we can have two different values, and this means I can have two sections. This is section 0, and this is section 1. And for each of these sections, I can have 2 to 7 different devices. That's about 128 devices in each section. So these are in different sections. I mean, the first bit of all of these the first bit of some of these is 0, and the first bit of the rest of these devices is 1. So they cannot talk to each other because they are in different sections. I have, put a barrier between these two sections so they cannot talk to each other. Otherwise, unless there is a router between these two. That's okay. Now I have two sections. Each one have 128. What if I want 4 sections? What if I want 8 sections or 7 sections or things like this? If I want to have more sections, what I need to do is to, draw this wall somewhere else. This is a 4th, 5th, 6th, 7th, and 8th. Now I want to have, for example, 4 sections. To have 4 sections, I need to put the barrier here because now I have 2 bits for section ID. So 2 to 4, 2 is going to be 4. So I have 4 different combinations for this. And of course, I have 6 bits here. So 2 to the power of 6 is going to be 64. So I have 4 different sections. And in each section, I can have up to 64 devices. So they are in 4 different sections. Again, they cannot talk to each other unless there is a router in between them. So now you know now you get the idea, okay? Now you know that I should put this barrier here. How can I put this barrier here? How can I tell that one IP address is different from another IP address? Not different. They are in different sections. I should have a value, and I just write that value with Y's here. That gives me an idea of this. So here is my IP address. Again, I'm talking about only 8 bits, 6, 7, 8. And I have my subnet mask. This is my subnet mask, okay? So based on this subnet mask, I know that which portion of this IP address is section ID and which portion is what? The host ID, okay? So how can I tell that? again, the subnet mask is a binary value. If bits are 1, this means this bit is going to be for section ID parts. For example, this, and assuming that this is 1, 2, and the rest are going to be 0, for example. And mostly they are contiguous, and of course not always, but mostly we can assume that the ones are consecutive and zeros are consecutive in sequence. So I know that I have 3 ones in my subnet mask, so this will give me that barrier. So I know that 3 bits are for section ID and 5 bits are for host ID. If I had 4 bits set to 1 in subnet mask, I would put the barrier in the 4th place. If I had only 1 bit set to 1 in subnet mask, I would put the barrier in the 1st bit. So now you know that we have 2 different parts in our IPv4 address. So you can generalize it, and you can go and tell that we have 32 bits. And again, from my 32-bit subnet mask, some of them can be 1, some of them can be 0, and again the barrier is the fine line between ones and zeros. And I couldn't find the correct word for this. So now you know how to set this barrier here. Now, what this section ID means, actually, when I'm talking about sections, I'm talking about, for example, different cities. Assuming that I have, for example, this one, 2 bits are set for section ID using my subnet mask, and the rest of the bits, 6 bits, are for my, host part. So this means that I have 4 different sections. This is my second, this is my third, and this is my 4th. And this section ID is 1. For example, here, this is going to be 2, this is going to be 0, and this is going to be 3. So I have 3, 1, 2, 3, sections 3, 0, 1, 2, 3. And again, I have up to 64 items here. Again, they can start with 0, and they go 1, 2, 3, 4, 5, 6, 7, 8, and the last one is going to be 63. So this one can have again 0, 1, 2, 3, and up to 63. And this one again 63. And again this one 0, 1, 2, 3, and this goes up to 63. So when I want to talk about device number 3, how can I find which device I want to talk about? Actually, I refer to the correct section using this part of my IP address and find it in that section. This means that if I want to talk about device 3 in section 2, that's going to be this device. And if I want to talk about device 3 in section 0, that's gonna be this device, okay? So I know that there is a logical grouping of devices in different sections. So let me go and generalize it to all 32 bits here. When I want to talk about 32 bits, I need to put 32 different X's here. And of course, again, for subnet mask, I need to put for 32 Y's here, and there should be a barrier between the places that we have bits 1 and we have bits 0. That's it. Now, if they're in different classes, for example, in class A, we put this barrier in a known area. These are the default subnet masks. For class A, I need to, I write 1x, 2x, 3, 4, and this is too wide actually. Let me write them a little closer. Of course, I can just write zeros. That's easier to work with zeros. 3, 4, 5, 6, 7, 8. This is the first part. And again, I put this dot here. This is not necessary in binary notations. I'm just showing this to conform to the traditions, huh? 2, 3, 4, 5, 6, 7, 8. And again, 1, 2, 3, 4, 5, 6, 7, 8. Now I have 32 bits for class A, and for class A, in subnet mask, I put 1 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0, and again 0 0 0 0 0 0 0 0. Now we have 32 bits here, and you know that I should put this fine line here. That's because I have 8 bits set to 1 and the rest of the bits are set to 0. This means that I have a barrier here. This means that class A is 8 bits masked, and those bits that are 1 actually are masking these bits. That means again that I can have 2 to 8 different sections. That means 256 sections. And again, I can have 2 to 24. That's gonna be about 16,777. I don't remember the rest of this, so I put a 0 here. About 16 million different devices in each section. That's gonna be a lot of devices in one section. So this is the default mask. We do not have to conform to this default mask. We can define our own, subnet mask for each IP addresses. But if you see values from 0 to 127 in the first octet of an IP address, you know that that IP address is going to be class A address, and that's gonna have 8 bits of mask, of course for default subnet mask. So let's talk about class B. In class B, I put the barrier in the second octet. Actually, they have 16 bits masked with subnet mask. So if you see class B, this is going to be /8. Okay, I just write and slash, and after that I write the number of bits that are masking my IP address. Okay, for class B addresses, as I told you, this starts with 128. Now I have remembered it. You can just calculate it so fast, so you don't need to remember this. But this is gonna be your second nature, of course. So this starts with 128 and ends with 191, and it has 16 bits in subnet mask, masking the address. For class C, it starts with 192 and ends with 223, I guess. Yes, to 223. Am I right? I should refer to the previous section. Yes, it has a default mask of 24 bits. And for class D, we do not go for any default mask. Actually, we do not even write a class D IPv4 addresses. We use that for multicasting. So, if I want to convert the subnet mask into decimal, what I will get is this. The first octet is all ones, so it is going to be 255. And the rest of the bits are 0. So the second octet is 0, the third octet is 0, and the fourth octet is 0. This is the default mask, and of course you can write it with a /8 notation here. So for class B, actually the first two octets are all ones. So this is going to be 255, 255, and the rest of the bits are 0. So we have two octets with a decimal value of 0. For class C, we have 24 bits set to 0, set to 1, of course. It is going to be 255, 255, 255, and finally we have an octet that is set to 0. So these are the default masks for different classes. Okay, now I want to give you another mask, of course. They ask you, if I give you a class A IP address with default masking, how many sections do you have? And actually, these sections are networks. How many networks do you have? And how many devices can you have in each network? And you know that how it goes right now. We have 2 to 8 different networks in different sections. So I write 2 to 8 networks. That gives me about 256. And of course, 2 to 24 hosts in each network. Huh? That gives me about 16,777. I don't remember the rest. I don't remember the rest. And actually, let me start the calculator and give you the exact amount of that. So if I go to programmer part, the scientific part, and type 2 and click on X to Y and type 24, this gives me, yeah, 16, 77 to 16. That's it. Now, if they talk about class B, this gives you 2 to 16 networks. That gives you about 65,000 535 or something. Let me find it. My math is so horrible. So 2 to 16. It gives me 536. 536. This is one less than what I wrote here. Okay. But that's it. And in each section, you can have 2 to 16 hosts in each network or in each section. Okay, that gives me again 65,536. What about class C? In class C, we have 2 to 24 networks, and that's about 16 million. And something, and it has 2 to 8 hosts in each network. Okay, so we have 256 devices in each network. Now, in next section, I want to talk about unusual masks. Actually, we do not use default masks too much, too often. We do not go for default masks. They are useless, actually. They are useless. They are just for your education. They're just for learning. But I want to set my own mask in the next section.